over 48. Okay, so this is your C1 expression, and this is your equation number 9. And then at x is equal to L over 2, we have equation number what? What do we say? Equation number 3a will be equal to equation number 6. Equation number 6. So we look into equation 3a. Okay, so where is equation 3a? Okay, so that is my equation 3a. I'm going to take the whole thing. Copy. Go to the next slide. So that is our equation 3a. Right? And this will be equal to equation, I'm looking for boundary condition. Equation number 6. Okay, so I'm going to grip from equation number 6. Okay, so that's equation number 6. Right? So it's going to be, okay, so over here, we can get rid of this. We can get rid of this. Okay. Then we're going to, so we have our C3 and C4. We know our C1 also, right? So if we look at our C3 and C4, right? If we go to, so C3 is equal to minus AY L squared over 2 plus Y omega L cube over 24. And then C4 is also AY L cube over 6 plus omega L 4 over 4 minus by C3, right? Oh, sorry, we are good. Yeah, this is your C4, right? This term over here, right? So you realize that now we can solve for just AY because all the constants are a function of AY now. Yes or no? So if I'm going to write this out, okay. So if we look at, so we know that our C1, right? We know that our C1 is equal to minus AY, okay, AY L squared over 2 plus by omega L cube over 48, right? That is our C1. Then you put a bracket. This is X, right? The rest of the term, just leave it first. Virtual minus omega L squared X squared over 16 plus, so we going to substitute our C3, right? So this will be equal to minus AY L squared over 2 plus by omega L cube over 24, right? Then you have to put in your X and then plus by C4. So this is equal to AY L cube over 3 minus by omega L4 over 48, right? So you realize that the entire term over here is just AY left, right? Right? You can find your AY now. Okay, so so now is just matter of substitution, right? So you need to substitute X is equal to L over 2, right? So this will be equal to minus AY L cube over 4, right? Because X is L over 2 plus by omega L4 over 96. Okay, and this is equal to minus omega over 24. So this will be equal to L4. So 2 to the power 4 is 16. Then plus, but you have to be really, really careful over here. A lot of times students make any mistake is here. 2 to the power 3 is 8 minus by omega L squared over 16 L squared over 4, right? And then this is equal to plus and then minus AY L cubed over 4 plus by omega L 4 over, see, I'm lost already, 48, right? Because over 2 plus by AY L cubed over 3 minus omega L4 over 48. Right. So is there anything that I can scrub off? Yeah, we can scrub off this term over here and this term over here. Anything else? So we left with AY. You cannot get rid of all your AY. Yeah, get rid of all your AY, we're in trouble. Okay. So finally, so I'm going to let this will be equal to 0. This will be equal to minus omega L4 over 96. Okay. So minus omega L4. Okay, so all your term has to be omega L4. Then you know your equation is correct. If not, you'll be in trouble. Okay. Then plus by omega L4 over 96. Right. So minus omega L4 64. Right. Then plus by omega L4 over 48 plus by AY L cubed over 3 minus by omega L4 over 48. Okay. So by looking at this, I can cancel, I think I can cancel this. I can cancel this. I can cancel this. I can cancel this. So finally, this will be equal to minus 1 over minus 1, minus 1 over 384 minus by 1 over 64. So minus 7 over 384 plus by omega L4. So this will be plus by AY L cubed over 3. So therefore, your AY will be equal to omega L over 384. No, not 384. So 7 over 384 times 3 is 7 over 128. And it's positive. Positive means what? It's going upwards. Okay, so when solving this, positive means it's going upwards, negative is going downwards. And positive is correct, it's valid when it's going upwards because of the load over here. Okay, if you look at our beam, our original problem, right, the load has to be acting upward over there. So now we have for AY, then all we need to do is to sketch the bending moment diagram. Okay, so we have to sketch the bending moment diagram. Then to get the bending moment diagram, so we need to look at equation number 1a. Okay, so you look at this equation over here. So I'm going to copy the equation. So I'm going to put limit 0 x to L over 2. Our bending moment equation equal to this. Okay, so we have m as a function of x is equal to ayx. So it's equal to 7 over 128, right? Omega Lx, right? So we know that the function is a straight line. So when x is equal to 0, right? M is equal to 0 also, right? So when x is equal to L over 2, M at L over 2 is equal to 7 over 128 omega L multiplied by L over 2. So this is equal to 7 over 256 omega L squared. Okay, so we know the specific point, or so 7 divided by 256 is equal to 0.02734 omega L squared. Okay. Then we look at when x is equal to 0 or L over 2, x to L, M as a function of x. Okay, give me a few more minutes. I'm almost done. Okay, M as a function of x. So you go to the other equation now, okay, which we have formed. So A to C, we are looking for C to B, C to B. So it's this expression over here. Or I'm going to copy the one below. Right, so this will be equal to minus omega over 2 x squared minus by xl plus by L squared over 4, and then plus by AY. So AY we know that is equal to what? 7 over 128 omega Lx. Okay, so we know that is that expression. So the next thing that we do now, okay, we're going to substitute when x is equal to L, right? So we're going to substitute x is equal to L. So it's the last point. So M as a function of M, L, or L, I mean M when it's at L distance, so minus omega over 2. So this is L squared minus by L squared plus by L squared over 4. So plus by 7 over 128 omega L squared. Okay, so this will be equal to minus 1 over 8 plus by 7 over. So it's equal to minus 9 over 128 omega L squared. Or, okay, so 9 divided by 128 minus 0.0703, right, omega L squared. And then probably you guys will have remembered this. So we know that from 0 to L over 2 is a straight line, right? And then L over 2 to L is going to be a curve. Okay, so we have to find the peak of the curve. Okay, where is the peak of the curve? Okay, so between point C to B, okay, we need to find the peak. Find Mmax, right? You want to find Mmax. So to find Mmax, right, we just need to differentiate, right? We need to differentiate equation 4a, right? So we need to differentiate dm, okay, by dx, right? So dm by dx will be equal to, so we differentiate this term over here, right? So this will be equal to, so 7 over 128, or I'm going to do the inside term first. So differentiate. I'm now having a brain fart how to differentiate. So equal to minus omega x, and then this is equal to minus will be plus by omega L over 2, right? And then the last term don't have, so plus by 7 over 128